Production, 15 plus years in networking. I can't go into the plus part because that would disclose my age, but back in those days, ATM was cool and the redundant links were kept in disabled state. So, experience in enterprise, financial services, service provider, and research network. At this point, I'm part of Bloomberg CTO network architecture. I look into future directions in networking, often finding long forgotten past. So, quick introduction to Bloomberg. It's a relatively well-known media company. Also happens to be a technology company. We do employ a lot of engineers. We design networks that have the requirements of enterprise. We act like service provider. We act like content provider, and occasionally an advanced research lab. We do have a lot of data that we need to process. And we also happen to maintain higher availability than pretty much everyone else in the business is about. So, when I was doing research in disaggregation, well, what's the first thing you do? You look in a dictionary. And so, how does dictionary define disaggregate? To separate from a group or mass, to divide into parts. Division is good, we divide and conquer. Then I started reading further definition. That's how medicine defines disaggregation. Again, we break it up into component part. Then the second definition was kind of alarming. Inability to coordinate various sensations and a failure to observe their mutual relations. We definitely don't want that. And so the question is, how do we get one without the other? And which one? So, what is actual network disaggregation? As how I understood it, or how we try to define it. So, there are original device manufacturers, and they build the device. Most of them are somewhere in Taiwan. Then there are integrators that put operating systems and various control and management applications. They also put middleware, but they never tell me about it. Some vendors actually make all of the above. We know them as our incumbent vendors, and they create giant integrated software packages. And that's why some, code packages are 1 gigabyte in size. It should not be confused with white boxes, because white box is just a non-branded concept. So probably at the point when it showed up to the vendor's warehouse, it's actually a white box. Most people, whether they buy Edge or Arista, actually don't buy white boxes. So, why you could be interested in this whole thing? Well, some people are interested in alternative vendors that may have different approaches to problems. Often, and I think that's something that frequently comes up for us, and I'm sure comes up for many other people, is you say, oh, I wish this vendor X could do protocol Y and run on hardware Z. And it just so happens to be that some CTO at that vendor X decided that a certain protocol Y really sucks because their rival in another vendor came up with it. So, you discover protocols and ideas and without discovering an actual product to go with those ideas. Sometimes for good reason, sometimes for bad reason. You're tired of network device type best practices. Even though it's 2017, we still believe that some devices are switches, some devices are routers, some devices are firewalls, some devices are load balancers. What if we thought of all those things as just features and capabilities and forgot the whole monolithic device? Anyway, you want things that are modular, loosely coupled, and open. Modular being components that are separate and interchangeable. Loosely coupled, they don't have too many dependencies. And open, you can change all kinds of behavior. And that includes all kinds of behavior. Even the behavior that you shouldn't be changing, but you may want to at some point. Or you hire a consultant to do that. You actually start wondering if operating system is just a facility. What if we actually thought that, we're buying iOS, we're buying Junos, Arista EOS, not for the operating system, but for certain interesting protocols that the vendor implements. What if, what if operating systems are possibly irrelevant? And people in the operating system business have been talking about it for a while. Ultimately, the goal of operating system is to get hardware, software, and middleware working together. Now, what if routing protocols are just distributed applications? And what if everyone's favorite and hated CLI is just a primitive form of intent-based networking? I mean, I know intent-based networking is popular, but if you have something that lets you configure something in one command, how is that not intent-based networking? Some less interesting news. Well, disaggregated networking is not always cheaper, which has been its positioning for a while. Definitely not cheaper if you replace vendor device with alternative disaggregated device. If you're going to take probably a Cisco Nexus and right next to it put an edge core on top of which you add an operating system license, on top of it you may add some kind of management agent and all that, may not be quite as cheap as you thought. In fact, most industry analysts apparently agree with that. It may become cheaper at certain scale, but you got to develop a system around it. It will probably become cheaper if you start challenging common best practices about device type. What if you actually started thinking of your switch as an actual core router? What if you started thinking of your server as your network edge? And maybe then you would suddenly realize the promised cost savings. Anyway, disaggregated networking will not turn you into hyperscale. So every time you think, oh, well, I want to become like Google and Facebook, it's a process that will make you Google or Facebook. Try adopting continuous integration model and see what happens. Life probably won't get easier if network devices become like servers. I mean, it's a big push, but actually servers may become a lot more like network devices, and certain ideas about managing network devices may actually go to servers and not the other way around. Disaggregated networking will not make it easier to automate. It won't make it easier to build your proverbial VLAN between 5 switches. And why would you even want to automate configurations if you can do actual, better protocols? I mean, why even have some configuration in certain cases? Anyway, and a lot of people say that that operating system changes will be easier in disaggregated network. Well, for people who have to upgrade vendor code, just imagine if you're completely changing your operating system. Will that be easy? Probably not. And again, the point is, why change an operating system if you're really after network stacks and their applications? So change those. Anyway, so what's the point of this whole thing? Disaggregation, it treats your networking as just another application. You get to fail with a lot fewer consequences, hopefully. Your standard documents become recipes in a cookbook, and you discover just how many crappy standards are out there. You buy tools. You no longer have to buy an entire toolbox and be stuck with it. Now, disaggregation also happens to be a great opportunity to bring even more complexity. If you think the network is a kludge, it may become a much bigger kludge. Your incumbent vendor has been trying to shelter this. And actually they mostly have done a pretty good job. And so the biggest thing that you need to do as you get into this is start understanding your components. And unfortunately, understanding of most of the components in a typical networking is very annoying. Anyway, so this is disaggregated networking at a glance of something that I threw together. You've got hardware, you've got your operating system, you've got your abstraction layer, you've got all of your different adaptation layers, somewhere you've got also in certain systems software forwarders, and then finally you have your network application. For most of us who have been traditionally buying network devices, we've never even bothered to look at anything beyond the top and the bottom. And occasionally we would go through a day in the life of a packet. We would extensively study it, and then we'd forget it the first time. We would need to troubleshoot why a route isn't getting into a format. And that PowerPoint would be gone. Anyway, so the first thing that you need to know, and that is probably one of the more annoying things, is your auxiliary hardware. Sometimes you're like, okay, I'm going to buy this switch, it's a Broadcom switch. Well, Broadcom is a little chip. Somehow this Broadcom, somehow this chip turns into a big switch with all kinds of weird things in it that you really don't. Most of us don't want to know about, but we do. So the first thing is that you've got your layer 0, layer 1 network elements. I mean, they're important because at least you need to know if your port is up or down. And all of a sudden you may discover that certain of these elements, ranging from optics to some kind of like specialized modules, suddenly don't quite work because they require some kind of specialized device drive. So all of us, and guess what? The incumbent vendors, despite all of their complaints about unsupported optics, actually have done a relatively good job at support. Your certain non-incumbent vendors, in an effort to release code, may forget about those. Then you've got your fans and other environmental controls. That's even more annoying than the optics. Apparently, if you're running a system that's got all those controls, they all need to work, they all need to report to the system, and you need to have device drivers. And apparently, almost everyone tries to build things a little different. You've got your control motherboard, control CPU, management board, storage, and all kinds of things that go on the server. So suddenly, you go from from a network engineer to some kind of like server admin, and many of us went into network engineering because we wanted to avoid that. But all of a sudden, we need to understand. And your so-called network packet processor can be thought of as a NIC. So before you know it, you are actually dealing with a server, except some weird kind of server that doesn't look like that. Or your CPU is a compute node of the packet processor. So now you got to figure out so now you've got a network inside the network. And then once you realize that all kinds of connected things make up a network, so it's no longer enough to understand your real network, you've got to understand the internal device network. It really gets different. And then you need to understand what goes to the CPU, what actually transits the packet process, and, well, we've challenged the best practices, so apparently we have to care about all these things. You also need to know your packet processor. That's kind of like your most important part. So the first kind of packet processor is everyone's favorite ASIC. It's kind of like, it's been designed kind of like as a race car to run around a few tracks. You build it you bring it into a city, and it becomes kind of inefficient. Anyway, it's designed for a specific set of functions. They have fixed pipelines of multiple function tables, and they're designed for a set of specific operations. Some advanced ASICs support more function tables. They can do more complex operations, and you'll find them in most campus and data center switches. You'll find them in other devices, but they may be relevant to this conversation. Then you've got FPGAs. I've seen like 1,000-slide presentations on FPGAs, and there's a lot. But from what I was able to extract, it's kind of like it's kind of like an ASIC, but with an ASIC, if you got a certain sequence of various logical arrays. In FPGA, you can rearrange them any way you can. So all of a sudden, you can do all kinds of sequences of packet operations. So you'll find them in more advanced network devices. You'll find them in load balancers. You'll even find them with a few switches out there in the market. And these switches will be positioned as something, for example, that can do millions of open flow. You're like, what do you mean? It's an FPGA switch. So it always helps to note the pipeline of a switch. So I took two of the more relatively popular, switches, and that's what happens with the packet of those switches. So kind of you see the difference between how Broadcom handles things, where it's a pipeline of different operations, versus say Cavium explained, which is a little bit more advanced, which is kind of like a pipeline of several tables. And then you're like, well, if that's the case, then maybe certain operations are possible in one and not necessarily possible in the other. It also helps, for your incumbent vendors to provide that information, because then customers ask less annoying questions. Anyway, you need to also understand your more advanced packet processors. I mean, there are NPUs. They're, you'll find them in high-end routers. Some of the more popular ones are, QFP found in ASR, Trio found in, Juniper and Nexus. But they actually are, compiled microcode, and they can also work in parallel. They can do all kinds of fancy things to your packet. They also happen to cost a lot of money, and even when you don't need to do all kinds of advanced things to your packet. And they also, they also advertise all kinds of other capabilities. Anyway, there are also the CPU systems. They're actually, that's what you find in a typical server. And people make attempts to turn servers into network devices. And, well, some of these attempts have failed. And because it's a general purpose CPU. It can do everything, but, it's like a multi-purpose car. You can't really take it on a racetrack unless you heavily modify it. And there are a lot of vendors that specialize. But ultimately, what we've noticed about all these like CPU systems is you try to have multiple CPUs, you try to have multiple cores, all kinds of things start going wrong. Anyway, so here's an example of an NPU. It does actually look like a NIC, something that's got many ports, it's got access to memory, it's got access to the fast memory TCAM, it's got access to slower memory, it's got access to CPU. And if you start thinking about it as a single unit that resembles a NIC, it becomes a lot easier to understand. Anyway, you need to know your operating system. The operating system is a facility, but it's kind of important. I mean, most of the operating systems are variations of Linux. In fact, both on incumbent vendors and on non-incumbent. Some use other operating systems, some use specialized other Unix microkernel systems. There are specialized embedded systems, but most people want to go down the Linux route, even if it's a specialized Linux. They use bootloaders. The most popular are Grub and Omni. Now, the next thing becomes is what your operating system actually does. In the most ideal world, your operating system doesn't do anything except does device drivers. But know whether it's a facility or it actually does middleware function. And if your operating system is a bit of a middleware, you start thinking about how different control protocols actually work. You need to know where your device drivers are. And you ideally want your device drivers to be as portable as possible. In other words, all the components that drive actual hardware idea should be decoupled from your operating system. Anyway, know your abstraction layers, or how a route becomes a bit string in the memory. Again, you've got your control systems, they need to be compatible. It's quite impossible to get every control application to work with every hardware. And limitations arise. So you've got middleware, and that's your middleware with northbound and southbound interface. I think some people actually call it SDN. So you've got your northbound interface to your routing system, you've got your southbound interface to the device driver, and ideally you have as few middleware layers as you can manage and make your system as portable as possible. So they apply to pretty much everything. Again, here's an example of a switch, and here's an example of a software formula. Anyway, you need to know your network application. And the biggest thing to know about network application is it's pretty much your routing protocols, it's your configuration managers. And the biggest thing is to know that you've got your protocols, you've got your RIB that accumulates all the information from those protocols, and you've got a network service manager that actually puts all of that information to the middle. And before all those commands that you did all apparently correspond to a whole set of separate processes in a distributed system of several tiers. Again, your vendor was nice enough to shelter you. Anyway, so what's the future of this whole disaggregated network? And of course, hyperscales are doing it, so let's leave that out. Actually, for now, it appears to be in the SD-WAN and in the data center, as the data center space, i.e. putting host-based for. There, obviously, most network vendors are branching towards commodity packet processors. You've got open organizations and open source projects. Unfortunately, you don't have that many interesting applications. And I think the only way to move this forward is if you actually start developing applications that are going to start turning your networking into pretty much the same way you've got your applications on your phone, or at least on your little server. Again, you'll have more flexible hardware, more flexible applications may appear. Probably, let's see what the integrators are going to do, which I won't name because I'm not allowed to name vendors. Anyway, really, disaggregation is actually all about humans, as many other things. Again, networking was always disaggregated. We just didn't know or care. Well, the right people knew and cared, but most of us engineers did not. And desire to care is actually the prerequisite. So you really need to start understanding how your network devices work. And the benefit is you may have one vendor, you may have a dual vendor strategy, but the whole combined community of the world that produces networking ideas is still there. You just need to figure out how to use it, so you need all the networking ideas you can get. And as in the previous presentation about will I be replaced by a script, it's yes, no, and maybe. Anyway, if you need to know more, and by the way, it's useful if you never even disaggregate. And it also helps your vendor as well. Vendors should be interested in educating customers. Anyway, study network devices. The incumbent vendor is your friend, because the incumbent vendor actually put a lot of that information out there. Anyway, never miss an opportunity to mix apples and oranges and ask questions about why something has to do that and not something else. Again, feel free to make up your own network protocol or system architecture. Don't use it in production without proper testing. If you've managed to properly test it, then maybe you can consider it. Use configuration neutral sources, and if you have to look at configuration examples, see how, say, I don't know, your vendor, you have no idea how it works does. And when in doubt, go to Linux networking. It'll be potentially sometimes annoying, but it does help you understand things better. Anyway, there are a couple of books that you can read. Ideally, now, so the third book, I mean, the first two books seem maybe kind of obvious, but the third book is interesting because the two people who wrote that book back almost like 12 years ago, I mean, you can only do so much when writing about routing protocol without just rewriting the RFC. But this is the first, I think, book that started appearing in the 2000s where people started throwing ideas that later became SDN, concepts of the original open flows, because after about 50 pages they ran out of what to talk about ISIS, so they needed to fill out additional 300 pages. So, but the book is actually interesting. And let me say, I started reading actually the first book to start preparing for this. And yes, it will put you to sleep. But it's worth it most of the time. Anyway, there are additional references and ready for questions.
Questions? Let's give them a hand first of all. Very hot. We're working on the air conditioning situation. So thank you for speaking in these heated conditions. What questions do you have for speaker number one?
In terms of the lessons learned that you spoke about, is that mostly from testing in a lab, or is that something you guys are going to production with, or are you already in production with?
So for the production, we've honestly yet to find our, shall we say, killer network application. A lot of it was done from various interpretability tests, things we've done in the lab, extensive studies, looking at architectures and talking to other people. And we've discovered the world that we honestly were not prepared for.